So in this lesson, we're going to tackle fractional exponents. So let's try an exercise. Take out your TI calculator when you have a moment and enter 4 raised to, I'm going to put it in parentheses, we're going to say 1 divided by 2, or 4 raised to the 1/2. I get 2. Let's try 9 raised to the 1/2. See what I get. You'll notice I get 3. And we'll do one more. 25 raised to the 1/2. And you'll notice I get 5. Now think about this. The square root of 4 is 2. The square root of 9 is 3. The square root of 25 is 5. So I guess what I'm trying to say here is raising a base to 1/2 is the same as taking the square root of that base, right? So 25 raised to the 1/2 is the same as saying the square root of 25. And you'll see I have the square root of 25. I press enter, right? There's no difference, right? Whether I say 25 to the 1/2 or the square root of 25, I get the same answer. Now let's try 1/3. Okay, if I take 8 and I raise it to the 1/3, you'll notice I get 2. If I take 27 and I raise that to the 1/3, I get 3. So the cube root of 8 is 2, and the cube root of 27 is 3. So 27 to the 1/3 is the same as saying the cube root of 27. Right? So here's me taking the cube root of 27, and you'll notice I get 3. Incidentally, this cube root function, if I press the math key and take a look at number 4, that says cube root, and I can put in a number here. I'll put in 8. So I'm saying the cube root of 8 is 2. Okay? So let's take a look at a few practice problems. It says evaluate each of the following by changing to radical form. So 1 to the 1/3 in radical form looks something like this. Right? So 1 to the 1/3 is really the same as the cube root of 1. And the cube root of 1, we're saying, well, what number multiplied by itself 3 times equals 1? That would be 1. Okay, now if you're a little confused, let's take a look at I guess a formal definition here. If I have a base and I raise it to say 1 over n, what's on the denominator of this fraction, the n, goes into the index. So 16 raised to the 1/4, the 4 goes inside the index, right? Just like the n over here went inside the index, the 4 on the 1/4 goes into the index. Okay. If I had 1 over 36 to the 1/2, the 2 goes in the index. And remember, when we're talking square root, it's not necessary to actually write the 2 inside the index. So when I look at problem 28, well, first I want to handle the negative exponent by bringing the 9 on the bottom and then making the exponent positive. So here I bring the 9 down, I make the exponent positive, so we go from negative 1/2 to positive 1/2. Then I bring the index, which is a 2, and I'm saying what number multiplied by itself 2 times is 9? Well, that would be 3, or really the square root of 9 is 3. And again, I didn't have to put this 2 in the index. It's understood if I leave this blank, it is a 2. Let's take a look at number 30. Okay. All right, so I have negative 64 raised to the 1/3. And notice everything's in the parentheses. So let's rewrite this. So since the 3 is in the denominator, I place that in my index. The exponent's positive, so I don't have to do anything in terms of moving it up or down. So I have negative 64, the cube root of that. So what number multiplied by itself 3 times gives me negative 64? Well, negative 4 times negative 4 times negative 4 is negative 64. So the cube root of negative 64 is negative 4. Let's try number 32. So number 2, since my 2 is in the denominator, it's really saying the square root of negative 100. Again, I didn't have to place this 2 here because it's understood that this is a 2 if nothing's written here. So what number multiplied by itself twice gives me negative 100? There is no number, right? If I did negative 10 times negative 10, that's positive 100. If I do positive 10 times positive 10, I still get positive 100. There's no number I can multiply by itself to get negative 100 So my answer is not real. All right, number 34. We have the 8 to the 1/3 times 144 to the 1/2. Let's change to radical form and then evaluate. So the 8 to the 1/3 becomes the cube root of 8, right? The denominator's a 3, so I put that in my index. The 144, that's saying the square root of 144, so I put the 2 in my index. Again, I didn't have to. And then we're really saying what number multiplied by itself 3 times gives me 8? That's 2. Then we're saying, what's the square root of 144? Well, that's 12, right? What number multiplied by itself 2 times gives me 144? It's 12. And then what's 2 times 12? I get 24. So my final answer is 24. Okay, so that was fractional exponents in the form of 1 over n, right? Exponents in this form, right? We had a 1 on my numerator and then some number on the denominator. So now we're asked to examine some problems where we don't have a 1 for our numerator. We have another number. So instead of 1 over n, it's m over n. Let's take a look at some examples. How would I handle something like example 6? I have 27 raised to the 4 over 3. So the 3 is on the denominator, so that goes in my index. And the 4 is in my numerator, so that becomes my power. Right? So 4 over 3, well, you could look at this. The 4 seems to be over the 3. So we're really saying what number multiplied by itself 3 times gives me 27. That would be 3. And then we have to raise 3 to the 4th power. And if you look above, they kind of give us a little definition here. Right? A to the m over n is the same as a, and I place the n in the index and m as my power. Okay? And it can also be written this way. Right? The m can either go on the outside of the parentheses or actually underneath the radical sign. Either way is fine. When you look at another example, we have 16 to the negative 3/4. So to get rid of the negative exponent, right away they bring the 16 down, make the exponent positive. And now the 4 goes in my index and the 3 is my power. So you're asking yourself, what number multiplied by itself 4 times gives me 16? That answer is 2. And then you raise 2 to the 3rd power to get 8. All right, so let's try a few problems. So we're not going to handle all of these problems, right? We have problems 35 to 58, but we'll do a few of these to make sure you're comfortable. So number 36, we have 100 raised to the 3/2. Let's rewrite that using radicals. So right away, my 2 goes in the index, my 3 is the power. So what number multiplied by itself 2 times is 100? Well, that would be 10. And then we raise 10 to the 3rd power to get 1,000. So for 38, we have 3/4 as our fractional exponent. So the 4 goes into the index. The 3 is my power. So I say, what number multiplied by itself 4 times is 16? That'd be 2, right? 2 times 2 times 2 times 2 is 16. And then we raise the 2 to the 3rd power to get 8. For number 40, we have to handle this negative exponent by first writing the reciprocal of 81. We're going to write 1 over 81 raised to the positive 3/4. So the 81 we put in the denominator, we make the exponent positive, and then we're really saying, okay, what number multiplied by itself 4 times gives me 81? That's the 3. And then we raise the 3 to the 3rd power to get 27. So my answer is 1 over 27. When I look at number 42, this negative sign is not being touched by the 4 raised to the 3/2. So, you know, a lot of times people get tempted to do something with this negative sign. Resist that temptation. So number 42, the negative stays on the outside. The 2 goes in the index. The 3 is my power. We're asking ourselves, what number multiplied by itself 2 times gives me 4? Well, that would be 2. And then we raise the 2 to the 3rd power. And remember, the negative sign stays out here all the way through. Right? And then we're left with negative 2 cubed, which is the same as saying negative 2 times 2 times 2, which equals negative 8. Okay. Last one is number 44. So the 32, we move to the denominator and make a negative 3/5 positive. The 5 goes in the index. The 3 is the power. What number multiplied by itself 5 times will give me 32? That would be a 2. then we cube the 2 to get 8. Now it says, all right, write each expression in radical form. So we can't evaluate these, but we can at least rewrite these problems. So let's take a look. 46, we have y to the 2/3. There's not much we do here. Right? The index is a 3 and the power is a 2, and that's my answer. For number 48, to handle the negative exponent, we bring the x to the denominator and make the exponent positive. So I write 1 over x to the 5/2. The 2 goes in my index, and the 5 is my power, and there's my final answer. Last one, number 50, the 8 is not being touched by any exponent, so don't do anything with this 8. People always want to try and do something with the 8, but the 8 just hangs out by itself. And then the y, well, the index is the 3, so I'll take the cube root of this y, and then I'll square it at the end. And that's my final answer. And then, so we went from fractional exponents to radical form, and here we're in radical form, and we want to end up with fractional exponents. So number 52, there's nothing in the index, so I know it's a 2. So 2 goes on the denominator of my fraction, and the power is the 3 that goes on top. Number 54, my denominator will be 3, and my numerator will be 4, so I have 4/3, and everything in parentheses stays where it is. Number 56, again, my index is 5, so that's my denominator of the fraction. My power is the 3, that's the numerator. So I'm left with 1 over y to the 3/5. And for number 58, the 4 stays where it is. The 3 is my index, so that's the denominator of my fraction. The 2 is the power, so that's the numerator. So I'm left with 4 over a to the 2/3.